wanted to understand. So let's just give it a try one more time, and then it will be useful for everybody else if you have not done it. And I'll come back to that. What were we talking about? The risk management topics, right? There was something else I wanted to say. Where did we stop? Yeah, risk was one thing, and I think we moved on to something else. Maybe not. Okay, maybe I was only at risk. Okay, all right. So let's talk about the computation graph and backward differentiation. So two things here that we talked about yesterday. One was that when you are learning, you're starting with certain values. Okay, and let me see. I'll try to give some examples so that those people who have a management background can also relate with it to some extent. So you're trying to do the feedback loop. Okay, the feedback loop is simply saying that how do you connect or how do you correct whatever the numbers are. I took the examples of control theory or things like that, but you can apply it in any domain. Let's say you're trying to learn what's the right mix of production for a company, right? So you could think about it simply saying that there are 2 or 3 different products that you are producing. You're trying to find out what's the right mix to produce to maximize your profit. Okay, so instead of a loss function, you have a profit function that you want to maximize. If I want to continue to give the same example of a loss function, you might say that you started a new business and you are in a loss, so your goal is to minimize the loss. So that is a loss function. You are doing it for one company. Let's say you're doing it for 5,000 companies or 50,000 companies, which means that you don't have to do that calculation one time, but 50,000 times, which is what each neuron is doing. So we want to do this as efficiently as we can. So what we did for that, we said that if we can create a computation graph which depicts what our loss function is, then we can use, oh, it will work with that script? Okay, that's even better. Then we can use to really do efficiently computation in 2 passes. So what we did, 2 things there. One is in the sense that we said that we need to calculate the derivative of the loss, which we were just talking, which is really the change that is happening, and make the adjustment in the opposite of the change that is happening so that we get what our stated goal is. One of the fast way of doing is calculation is called back propagation. So think about what we are trying to do. Our goal is to minimize the loss function. We define the loss function. The loss function is dependent on the weights and biases, whatever that is, or you can use the weights and biases to say the cost of production, raw material, etc., etc. The way you want to do this is that the loss function gets computed only when the entire neural network has computed its calculation. Every neuron, 5 neurons, 500 neurons, 5 million neurons, all of them have to compute it. Once you've done it, then based on what the loss function says, you have to make changes to the weights and biases. The change will happen in the opposite direction. First the output layer, then the previous layer, all the way to the first one, right? That's what you would do this. So back propagation basically says that how can you do it fast by using the basic mathematical terms and do it very fast. So what we introduced is saying that loss function can be represented as a computation graph, because every function can be represented as a graph. So if you have a loss function which says C multiplied by A plus 2B, you can show it in a graph. If you think about it, these A, B, and C could be anything. B could be the cost of raw material, A could be the cost of machinery, C could be, let's say, electricity cost or cost of a person. It could be anything. So what we are showing here is that how do you execute one forward scan to compute the loss function and one backward scan to update the weights and biases that was going to compute this. So this was a very simple example of a very simple loss function. You start with certain values, you calculate, and you discover that the loss function is -10. And then we said that because there are 3 variables, you need to figure out what is the partial derivative of the loss function when you make change to one of these things. You're going to pick up the change that's required at each node and whatever these things are. Now, I'm not going into the exact detail of what we did because we are going into partial differentiation and then the chain rule of the partial differentiation here, but that's what basically we're doing. Those of you who know calculus would know that how do you actually create the differentiation of combination of functions, the addition, subtraction, multiplication of the functions. So that's exactly what you're doing. We are calculating derivative of the loss with a partial derivative of the loss with respect to A, B, and C, or a combination thereof. That's what we are doing here in each of these steps. And basically, and you could do it, I think this is already uploaded to the Google class, so you can walk through it where you figure out that what's the loss function and the derivative with respect to E with respect to C, C broken down in A and D, and then D with respect to B, and then you calculate those numbers and then you figure out what the change is. Then you do the backward pass where you are applying the changes to each of these valuations. In red, basically you're making those changes, and that's when you have figured out in a two-step process, a forward pass which calculates the loss function and a backward pass which calculate the partial derivatives and apply them. Now, this is the basic mathematics that's happening at every neuron level. So if you have 5 million neurons, this is getting repeated 5 million times. Okay? Now, we saw a table today where I said that the GPT-4 has 500 billion parameters. So assuming that each neuron has at least one weight and one bias, it may have more, because if the vector that is inputting into it is 8K, then each neuron has roughly 8K parameters, right? So 8K times this calculation is happening in forward direction and in backward direction. Now, as I said today, that majority of you would not necessarily be implementing it at this level because this is really the foundation model that's doing all this calculation. This was the whole idea, to have you understand. And unfortunately, as I said that, we could go into more mathematics, but what I would suggest that those of you who are asking to repeat it, go over this on your own, basic rules. The intuition here or the reasoning here is to simplify this mathematics so that we can do it fast. Because think of it, this is happening at every neuron and number of times of the input. Because if you are having 8,000 inputs, you are doing partial differentiation for 8,000 different variables, loss function, partial derivative of the loss function with respect to every input that is going in. So we needed very fast calculation. So what they did is that they figured out a loss function which is linear in nature, where the partial differentiation can be calculated much more quicker and faster. So that's what we are doing here in general. Now, you have any specific question? Because I don't want to hold the class in going into more mathematical details, but you can figure it out. Yeah? Okay. Yeah. Okay, right. So the multi-layer, okay, so the perceptron was the first physical implementation of a neuron. So at that time they started calling a multi-layer perceptron, but really there is no difference between a neural network, artificial neural network, or a multi-layer perceptron. The same things basically as it stands today. All right, great. Let's move on to what we were doing today. So I'll go back to, okay, still not connected to the network, so I can't send you, but that's fine.
We have tested.
Sorry?
You got the feed.
Oh, you got the feed, okay. All right, fine. Okay, so let's start with where we were talking earlier, which is right here. So this is what we were talking about, theory of mind problems and high level reasoning, right? And when we stopped, I said that let's try to figure out what these models cannot yet do. So anybody, any answer? What the model cannot yet do?
Comprehend human emotions to a higher degree of accuracy.
So the emotions as reflected in the text, like sentiment analysis, it can do very well, right? But if you say that, can it detect the human emotions from audio and video? It's getting better. It's getting better, but it's not there. But then I'll go back to on day one that which of the 5 senses can it do and emotions can it do or can it not do. Let me actually give an example here now when I know better the composition of the class here, in the sense that people have done the used the model to come up with a startup idea, make a website for it, let the model create the website for it, possibly create the entire business by providing it connectivity to sources and a delivery system. So obviously you're not creating an Amazon.com like businesses, but you could create a business, research an idea, generate an idea, create a website, create the backend system connecting with the sources or suppliers, and then create the entire supply chain using totally letting the underlying language systems to work on it. Okay, so that's instances where people have done that, created businesses totally utilizing the large language models. Okay, what can it not do? So this slide talks about it. Unfortunately, it's got lots smaller. I'm not sure how many of you can read it. I can't zoom it. Okay, all right. So basically what we're saying is that they are probabilistic models. So far, everything is sure, right? Now, what happens is that it is always trying to find the associations across the words, which is what the basic model understanding is. Obviously, we figured out that it is doing more than that. It's associating the concepts also with the words and trying to figure out is that what exactly these things cannot do. Now, it is always trying to inference. What it cannot do is that it cannot revisit its prior inference. So if you think about it, yes, there is a encoder model which is trying to use the both sides of the word to predict a prior word that it has seen, but in general the models cannot fix what they have already produced.
Connected.
So that's one limitation that we have. Obviously the encoder models are trying to do somewhat better and get rid of that drawback, right? The other thing that we have a problem with is because of the context window size is limited. And there is a possibility, or not possibility, there is a likelihood that it cannot revisit the prior prediction. There's a concept that has been observed called goal drift. So if you think about it, it's producing a B, F, H. If it has made a mistake, let's say here, there's a very high likelihood that it will never come back and fix it. And because it has already made a mistake, there's a high likelihood that it will not get the desired output. It will actually create something which is possibly not correct. So this kind of phenomena is called gold drift, in the sense that once it has made one mistake, there's a likelihood that it will continue to make mistake, because it's not going back. It's not going back. So that's one problem that we have, the gold drift a possibility. The way to do it is that trying to do the prompt engineering so that A, either you avoid it, B, you provided instructions to avoid having this kind of a gold drift. Prompt engineering becomes important there, right? We saw chain of thought, because you ask it to think through, ask it to explain. Again, you're not asking it to fix the mistake it made, you are providing it instruction or context so that it does not make the mistake in first place, because it still can, right? The other thing what LLMs cannot do is that they cannot set their context on their own. Again, the prompt engineering becomes important, because you are setting up the context and you're trying to make sure that they can basically not have this kind of a resetting of context, or they cannot. Chain of thought, I mentioned that, and then the prompt engineering, whereby you're trying to avoid these kind of problems, right? So again, I will say that in majority of the situation, prompt engineering is your best friend if you want the model to behave the way you want it to, or even in cases where you want to override its default behavior, push it into certain direction. Both positives and negatives. I gave you the example. People with the, again, some of them, you can think of them as a white level hacker. They said, listen, we can train this to use the bad words more often than it should be, or always, which is not required, but that's your best friend in the sense that you can actually provide it context, in context training, some supervised learning, some parameter tuning to make it do what you want it to do, right? That's the important point. So for example, let me tell you that one of my friends runs a startup which basically made a business evaluating your writing. So what you could do is, and that's a very doable thing, one of you was asking, is like, what can you do? So there are established formal way of assessing quality of your writing. So you can create a system using ChatGPT or any other large language model that can A, assess the quality of your writing, B, suggest improvements to your writing to make it better. Let's say you're writing a research paper, right? So you can train a model to judge your writing and say that where the deficiencies are. You can actually make it rewrite the paper as well, but if that's what you want to do it, but generally that's not something is a good practice, but you can definitely use it to get the quality of the writing. It can definitely do all kinds of things to say that your usage of word, repetition of the word, size of the sentences, all of those things which are defining the quality of your writing, it can do all of that. Okay? Error checking, correction, externalized memory, functional competence, fine. Now this is the last point that we have here. And actually this is also, eventually we will talk about it again next week. There's a concept here which I wrote called RAG. Has anyone heard the term RAG before? It's called retrieval augmented generation. So think about this way. The model, the foundation model's learning is limited by whenever it was trained. So if it was trained up to, let's say, data which was generated until December 31st, 2024, it would not know anything that's happening today, right? So there was a violent incident in one of the cities in America last night, right? The ChatGPT would not know about it because it hasn't been trained on that yet. So one of the way is to modify or enhance its capabilities called retrieval augmented generation. So if you think about it, like one of the companies that I work with deals with people who are having the either intellectual or mental disabilities. So if you're trying to solve a problem for that, base or foundation model may not have access to specific data points related to that. So if we are trying to answer a question related to them, what we do is that we use a technique called retrieval augmented generation. Now what we are doing here is that we are providing not just the in-context learning, which is going to be prompt engineering, but pre-training before the answer is attempted. So what we are trying to do, if you think about it, we are messing up with the distributions. We are giving them additional data so that they can actually, when they are sampling, they will give higher probability to the additional data that we are providing. How do we provide the additional data? Now that is something we're going to be focusing on going forward. Most of it tomorrow. I'll introduce the word today in the sense there's something called embeddings. So what happens is that all the data that a large language model is working with is called an embedding, and it's basically embedded in a graphical space or in a graph space. So what the retrieval augmented generation does is that it basically insert some additional information into the embedded space of a large language model, and then basically instruct it to provide higher probability. So the same thing, the bad words were inserted using prompt engineering. We are trying to do this for the right reasons so that it gets a better information. Okay? A very high level diagram here of transformer. Now we have not introduced these two concepts which are very important in a large language model. One is called transformer, which is a kind of an architecture, and a concept called attention. Okay? Those are the two things we will talk about tomorrow. So keep those in mind. In general, what happens, this is a very high level view of a transformer architecture. You start with a word, you predict the next word becomes the input to the next layer of the transformer, and then you keep going along this, trying to figure out all the time, minimizing the loss function. So we'll go a little bit more detail of this tomorrow. So not math, but a little bit of a algorithm or a computer science concepts tomorrow. But this would be the last we would learn about the details of it, and then we'll go on to the other risks, the capabilities, the use cases, the socioeconomic, political, legal implications of these models going forward, right? In general, majority of the data that they have used for training, I don't think you guys can see it, but it's called a public database, because that database is available to anyone and everyone. You can also access it if you want. That has been used to train most of these models, if not all. There's about 156 billion as of sometime last year, actually as of 2020. So they may have gone a little further than that. 156 billion words or symbols that have been used to train. Majority of this data was taken, stolen, depending on who you think you're talking to, from the Wikipedia, from the World Wide Web, from the digital libraries around the world. So everything that's out there in public domain has been fed into these models. So if you ask it to reproduce the Shakespeare's Hamlet, it actually has memorized it and it will write it for you. That's not the greatest use case. You may ask it to write or take your story and ask it to write in Shakespearean English. It can do that as well. It can take your story and write it as if Shakespeare is writing it. It can do that. Can it tell the story of Ramayana? No. because the original Ramayana has not been fed into it. There's an English version of Ramayana that's been fed into it. Does it know Sanskrit? No. So there's a lot of gaps there, but it has the commentary, or what we call in Hindi like tika, is the associated commentary on the original text, knows that, right? But it can't do everything. I mean, there's a whole lot it cannot do. So think of it. The basic lingua franca is English of these models. So anything in English, there is a 99.99% chance that it has already seen it. Anything in your code, if you are using any of the code repository, Gitbook, GitHub, any of those things, it has access to all of them. So it has seen all the code ever written for majority of the languages. So it might do very good code generation as well. So we'll talk about these things as we go along, right? So this was just showing in terms of what these sources are. So if you think about it, Bibliothèque was one of them, GitHub, DM Maths, Stack Exchange, Wikipedia, Open Web. If any of these things, if you have seen free law, US patent, all the patents information, which is in public domain, it has seen it all, right? But still, you know where the gaps are. All right, let's move on. So what is it is learning, right thing or wrong thing? So here are a few examples. What it is showing is that what it is producing as the next word. Some examples here. As you would see that, some of them are right, some of them are wrong. When it learns that there are canines everywhere, one dog in the front room, and two, it is correctly predicting that we are referring to dogs. It was just big, it was enormous. It is correctly predicting the next word, that big is related to enormous or enormous is related to big. If you say the author of A Room of One's Own, Virginia, it knows that this is not the Virginia state, it's the name of the person, Virginia Woolf. So it produces the right number. Where we have an issue, the doctor told me that there's a bias. It always thinks that the doctor is a male character. Right? We're going to talk about this next week as we know about it. Square root of 4 is 2. It's not computing. It cannot compute. But it has seen it so many times that it says square root of 4 is 2. So what it can learn, right? Not all of it may be right, but some of it is learning is right. So there's an enormous amount of knowledge which is in the text. It is figuring out the directions, relationship. But the pre-learning is whatever the language model that they give the ability of, or what it has access to in its corpus of data that's gone in there. So in general, that's what is going on. This picture is showing that. Pre-training data, everything that's published, pre-trained language, then the fine-tuning data. Now that fine-tuning data, as I showed you, a couple of different ways. Prompt engineering, model tuning, RAG, the retrieval augmented generation. We haven't gone into the detail of which. Most likely, I'll see if we can do it tomorrow. We'll probably touch base on it tomorrow, otherwise next week. And then you have a fine-tuned LM, right? So for example, it could be, let's say, I gave you one example of RAG is that we are trying to build a system for the people which are intellectually or mentally disabled. You might be creating a language model for, let's say, electrical engineers. It may not necessarily know everything about electrical engineering by default. So you take a pre-trained language model, you add more data, which is domain specific. There are specific language models. How many of you have heard of Wall Street Journal? Sorry?
Almost all of us.
Okay. Anyone who has never heard of Wall Street Journal? Okay, it's a newspaper, it's a business newspaper. It basically contains a lot of data that it has. So they have created a fine-tuned language model that can answer question about business performances, past performances, those kind of things. ChatGPT may not know about it, but Standard & Poor information, or for example, the Wall Street Journal database has a lot more information about a specific type of language model. So a lot of work is happening in that space, the fine-tuning the language model, more tuned for a specific kind of use case, right? Now, that kind of modeling can be a continuous pre-training also, because there is always a new data coming in. Depending on how much budget you have, how much money you have, how much compute power you have, you can do it, you may not be able to do it, right? All right, so now we introduce a few more terms here, and there's a little bit of math. I'm not going to go too much detail on math, I'm going to skip it, but let's introduce this new term called perplexity. So really what is happening, if you think about it, we talked about is pre-training and then how the sampling lets the model pick up the right amount of data. Perplexity is a measure of how well it will do if it has not seen the data beforehand. So remember, I said that there's a latent space, there is a behavior that we say that can it answer the question if it has not seen the question before? Because that's the measurement. So we needed a new measure to find out how well it is doing on that. Such a measure is perplexity. So how well a model does on a prompt that has never seen before is measured by this number called perplexity. I'm not going into the detail of how it's arrived at, but that's the formula by which the perplexity is calculated. So think of it like, because people wanted to know. It's one thing to say that it's giving me the right answer because it has seen the data before. Not a great thing to do. Any database can do it. You have all the data stored, it can just retrieve it and give it to you. With the language model, you want it to perform better on the unseen prompt or unseen data than just on the seen data, right? Again, you don't want to use the probability of the test set, because the probability of the test set will always give you the right answer. You want to use the perplexity. Generally, what we are trying to say here is that higher the perplexity, better it is for better it is the performance of the language model that you are building on the unseen data. I'm going to skip the mathematical part here. Okay, I'm going to skip these ones so we can actually come to a new topic here. Low rank adaptation, I'm going to skip all of this. Okay, all right. Let me try to get to something easy and simple. Based on whatever we have learned, and we spent some time on what it can and what it cannot do. How many of you have seen the examples of what it can do? One of you had asked the question about that, can it predict the violent behavior, I guess? What else can it do? So let's look at some of the examples here. So I'm kind of widening the scope a little bit. I'm going into machine learning now, which is a part of the AI. Large language models are part of the machine learning itself. One of the things that the AI or the machine learning is doing very well and very efficiently is detecting objects from an image or a video stream. I think the Tesla is not yet allowed in India, right? Yeah. So if you think about it, not only the technology exists, but it has been also commercialized. This is a screenshot from Tesla. As you drive a Tesla, you could see that it is not only capturing the image in a video stream, it's analyzing it, it's identifying every single object out there. Car, pedestrian, bus, truck, the size, the distance, and everything related to that. All of that is happening based on the machine learning model that we just talked about. Behind the scene, it's all the same thing. That's a reality that's happening today. The automated driving cars are actually using this to figure out, do they need to apply brake, do they need to basically do the course correction, or whatever the case may be. So that's happening, that's today. Okay? The machine translation. Machine translation is another possibility that's happening today. That's being done as we speak. and it is working very well. You can take a sentence, you can take a paragraph, you can take an essay and have it being computed and written back. Now, the word level prediction, that's the basic activity or basic functionality that's happening today as well. And let me ask you something here which is not on the slide. Have you heard of something called Notebook LM? Has anyone heard of it? Yes, no, maybe? Okay, I'll show you this one a little bit if I can access it here. I think it's not yet available in India or actually outside US.
It has something to do with Google search. That's
Yes, it's one of the Google products. Not search, it's one of the Google products per se. I'll come to it in a second. Other than that, if you think about it, there are more basic functionalities which exist. If you combine it with data science, those are the common ones. Predicting fraud, that's something which is happening. Now, predicting fraud from pure data science perspective was one thing. Combining it with the language model, it is doing a lot better now. Predicting health situations, likelihood of someone getting a specific disease based on their clinical results and possibly the other lab results. That's getting better day after day as we speak. So that's something which is happening here as well. All right, so that brings me to the end of what we were trying to do. Anyone else who knows or talks about another field? I'll see if I can show you what the Notebook LM is all about, and then where exactly we are going for. Any idea? Any questions basically at this point of time? Any suggestions? Any areas that you want me to opine on as the use cases for machine learning? Yes, no, maybe? Yeah?
both the definition of perplexity and machine learning was somewhere in the realm of learning from experiences without direct human intervention. So what's the rudimentary differences among the two?
Okay, so I would say that you're comparing apple and oranges here. So the definition of the machine learning that you are referring to is comparing the machine learning from other programming, right? And then when we say that it's learning, then we are differentiating in the quality of learning. And the quality of learning goes into, if you think about it, our original conversation on day one is the difference between knowledge and intelligence. So if the learning is only producing what it has been told, right, then it has a knowledge but not necessarily an intelligence. Perplexity is learning in a way or measuring the level of intelligence. How well can it perform on a task that has never seen before? So that's basic difference basically, right? Okay, any other question? Transfer learning and? Okay. So in both cases, you're starting with a base or a foundational model, right? In fine tuning, what you're doing is that you're providing it in context learning either by prompt engineering or tuning parameter or something of that nature so that it uses this new context to give you a better answer, right? In transfer learning, what you're saying is that I created this model, let's say, training it on historical papers written in whatever, risk management field. Now you're saying, can I take this and use it for, let's say, something else? Let's say, financial derivatives related research. So you're taking the weights and biases, all learning in weights and biases, learn using one domain and try to use it in another domain. That's the transfer learning. So if you think about it, one, you're using or trying to, so let's see. So this is a model, right? Or a base model or a foundation model. So in case of the one way you're doing, and this is the end user interacting. So the first level of expertise comes in when this person can do prompt engineering. You're doing in-context learning, right? Or what was the two things you used, transfer learning and fine-tuning. So this prompt engineering is part of the fine-tuning that you can do, and you can also do the parameter tuning. Still, you're using a UI provided or user interface provided by whatever the model you're using. Nowadays, the models are also exposing API. And I'm assuming all of you know the API, application programming interface, you can write code. That opens up for you to do something called the RAG, Retrieval Augment Generation, which means you are basically tuning the model, or more like extending the model, still the same base or foundation model, to do more than what the original intent was. Transfer learning says that I take the learning of this base model and apply it in a totally different domain. So let's say this was a language model. I apply it to on finance data. So I can call it as finance LM. So that's basically the transfer learning. This is not necessarily yet proven to be very effective, but it's being used, no doubt about it. A lot of companies are spending a lot of money on this transfer learning as well. Okay, any other question? You guys need to fix it. Any other question? Let me see if I can show you something here. Oh, I don't have internet connection. Hold on one second. Okay, it's connecting now. Hold on one second. Let me see if it's connecting. Okay. How did you do the screen mirroring?
Is it from here? Like, click on this.
This one?
Yeah.
Yeah.
And there is screen mirroring.
Screen mirroring. Okay. All right. Fine. Let's see.
Finding and so.
I don't know whether it'll work. I want to play some audio.
Sir,
No, it's not.
audio will work fine, sir.
It'll work fine, but it's not even mirroring it.
Oh, sir, just give me a minute.
Yeah.
Set of friends. It's not showing the session preference, sir.
Sorry?
It's not opening the session preference.
It's not doing what?
Session preference is not opening.
System preference is not
Yeah, I
opening.
think it's been open somewhere. So just
Click it.
it's on that screen.
Yes, it worked. All right.
And audio for the audio listeners. It's coming from that only.
Okay, all right, let me just read here. Okay, so this is the one of the company that I work with actually. So this is just a website there. This is what I wanted for you to see. Let's see if it plays out here.
Ever feel like you're juggling a million things at once? Like you're the designated driver, chef, personal shopper, and therapist, all rolled into one for someone you love?
Oh, yeah.
That, my friend, is a glimpse into the world of caregiving. Many of us are already caregivers, and many of us will be one day. And this deep dive is about exploring those waters a bit. We've got some fascinating material to unpack today. We're going to be looking at a new app, Ability Hub, that's designed to support caregivers.
Right.
But we're not just talking tech here.
We're going deeper, diving into the very real, very human needs it's trying to meet.
And those needs are immense. One of these sources we're looking at, so it's a study showing that caregivers can end up dedicating over 13 days each month to caregiving tasks.
Wow.
And that's on top of their regular lives.
Goodness. Imagine, just imagine juggling, cooking, cleaning, transportation, and a million other things for 13 days straight. Just like, whoa.
It's a lot.
Okay, so I'm exhausted just thinking about it. And it's one thing to list tasks,
Yeah.
but what does that kind of chronic pressure actually do to a person?
Well, according to the research, it can really take a toll. We're talking increased risk of depression and anxiety, trouble sleeping, even a weakened immune system.
Wow. I knew it was stressful, but I had no idea it could impact your physical health that much.
What do you guys think of it? That audio is generated by a language model. So as I mentioned, I showed you the website here, the Ability Hub. So the input were 2 documents that talks about the product. This is one of the Google products, still experimental. I don't think it's available outside US right now. It took a few minutes to generate the audio. It's about 8 minutes audio that got generated. So think about it. It consumed text, right? Now, that text was not part of the original learning because it had not seen the text. We wrote the text. We actually inputted the text into the model. The text was not written in conversational nature. I will actually show you the text also. It's a paper. It's kind of like a paper, or it's kind of like a document which is written here. It takes that document, converts it into a conversational script. Use that script to have a 1 male audio and 1 female audio. Introduce at the right time the exclamation, the surprises, the fact that says, hey, I did not know. Incorporates the number from the research which came in from our documentation. So, in terms of the capabilities, I showed you some examples earlier, right? It's getting a lot better. It's getting at the point where I can provide my own additional data on top of the base and foundational model. It can convert it into the conversational, but it requires a lot of power. So it only generates about 10 minutes of audio. It can't generate an hour-long audio yet. I mean, it can, but it'll cost a lot of money to do that because it's still costing the money. So the capabilities are increasing, and they're increasing a lot. I'm not sure if the audio is available. Actually, the document is available here, but it's not. Okay, what I'm going to do is that you can actually have an look at the abilityhub.io or AI and look at it and then listen to the deep dive audio. I'll upload the 2 documents which went in as an input to generate this audio on the Google Classroom. And then you can try to figure out is that the additional information that was provided to the base model and then what the model is doing to add that information, convert it into a conversational script, add all of these exclamations and surprises and the tonal information where somebody is actually being excited, happy, surprised, and then worried also if you hear the entire 8-9 minutes conversation. Okay? All right. This was just something that I wanted to show you guys that where the research is at this point of time. Okay. All right. So we are about where I thought we will stop here. Now let me ask you guys, are you ready to do a start of something else new? Or tell me something that you want to know about. We can talk about something else. Ask me any questions. We can do that. If you do not want me to start the next topic that we wanted to cover, we can do that as well. What we're going to do tomorrow is we're going to start, I think, here. Perceptron, yes. We'll go into the algorithms and the data structures or data, basically. All right, what do you guys want to do? Start on perceptron, or you have any other questions that you want to ask me and give you the answer? What is it that you want to do? Go ahead. Yes, no, maybe? Can we stop this? Let's just start this and then we can answer any question. Let me try to cater to the management side of the audience here. You guys have any questions for me?
Sir,
yes.
Sorry?
Neural network can mimic human behavior. So can it provide digital immortality of a personality?
You're making it very complex sounding it. What do you mean by digital immortality of a personality?
That's as my grandfather has passed away.
Yeah.
So then I want
okay. I get your point. So you're saying that has it reached a point where someone can create a digital twin of a person in a way? So if you ask me that question in the research labs, theoretically the answer is yes, right? Will it ever be available? Now these are the kind of questions we'll talk about next week. Like what are the ethical, I mean I mentioned the risks and biases and socioeconomic. We're going to talk about the ethical issues related to all of this, right? So theoretically it's possible, it's happening today as we speak in the labs. Will it be available for people? If you think about it, deepfake is unregulated, illegal use of the same thing, right? Now you said behavior. Now behavior is a slightly different thing. What you're going to have, or what the capability exists, is to take images, the audios or video of your near and dear, save it, have them participate virtually even when they are not there in future. All of that is possible. Incorporate them in your videos. Kejriwal used that a couple of weeks ago. Does anyone know what I'm referring to? He created a replica of Ambedkar and showed a video where he is getting, I haven't seen the video, but I know that. So that's doable. I don't know how they used it, but they figured out. They probably got it done from US or somewhere, because most of this technology is not available yet everywhere. So it's doable. Behavior, I don't know, because the behavior is difficult right now. The behavior would be that, are you really reflecting Ambedkar? Maybe not, right? I mean, but yes, replica, voice, image, you can copy. Now, that is the kind of question we'll talk about next week. Was whatever he did, was it ethical or not? That's the question. So the questions that we will talk about next week is no right or wrong answer. You can have, I mean, they did it. India has very lax laws right now. Maybe there are no laws right now. I showed you a couple of images from a couple of years ago where Pope was shown or Trump was shown, all of these things. So we're going to look into the ethical issues surrounding the use of technology. That's an area on its own. But good question. Some of it we'll cover next week. What else?
So,
Yeah.
so can we use these models in financial management, like for generating various types of reports and statements?
Yes. There is no reason why we cannot do. How many of you are familiar with 10K or 10Q reports?
10K and 10Q.
Yeah, I mean, so there'll be a little difference here because my, I mean, I have an advantage that I worked in so many different areas, but they were in different areas, right? If you think about it, I worked 9 years in this country before I went to US. Majority of that work was related to district level planning, remote sensing, and GIS. Then I went there and worked in the financial industry there first before I came to the academia. So 10K and 10Q are the quarterly and the annual filing by all publicly registered companies in India. I'm sure SEBI must be having a similar requirement here. I don't know about those things. So one of the early example of the usage of these models is the automatic summarization of the 10K and 10Q reports. So that's happening. The thing which is challenging right now is, can it do the analysis of the financial statements, balance sheet and P&L. Now those are open-ended. 10K and 10Q are pro forma. You have certain format and you basically generate the reports in the same way. Slightly easier problem to solve. Looking at the P&L statement or a balance sheet of a company and then trying to figure out, are they doing accounting shenanigans? Something difficult, not easy to figure out, right? So all kinds of things which are there. I mean, yes, you can train it to find financial irregularities, but not that easy, right? I mean, given the same financial statements, two chartered accountants can differ because one has produced it saying that it's legal, the other one might say that no, it's not legal. So all of these are open areas right now. Any other question?
So, how correct is this hypothesis of mine that as GPT keeps on progressing, the data would keep, I mean, we know that it is made on the future progress is done on the base of data sets of the previous chat model. So as you explained in that example A, B, F and H, since data point F was a biased or a like wrong data, and it's almost impossible for AI to head back to data point F and correct it. So as the AI keeps on progressing, larger and larger number of not accurate data would be fed into the system, and the end result would be, let's just say, it would end up being a data pollution case.
Yes.
So what's your 2 cents over it?
Okay, so two things actually. I mean, there's no question of what's the sense because most of it is research, right? People have already experimented. So I'll show you some of the screenshots of that. Basically, how many of you have heard New York Times? That's a newspaper basically. In my personal opinion, that's the world's best newspaper actually, if you ask me. New York Times did an experiment. I'll show you some screenshots of that next week, which basically said that it generated an output from the current knowledge of the language model. Then it fed back the same as like in context learning and generated the next one, generated the next one, and the next one. If I remember correctly, the 40th iteration, what was generated by the model was total garbage. So this is what I was saying, is that you're running out of the data. If you provide the synthetic data, which is the output of the language model, and continue to feed it this is not even a research. I mean, this is an experiment, if you want to call it, because to get to the research, it requires a lot more rigorousness and reproducibility. But a newspaper did it, and it says that after the 40th generation, what was produced was total garbage. I'll show you some of the screenshots basically next week. But that's a problem. That's a problem. So, but if you think about it, that's a problem as well as an open research area. I am not saying that this would never be solved. Maybe it will be solved. How it will be solved? Because the language model can change, the way we are figuring out the prediction of the next word can change. Instead of our understanding of neuron today, we can change something. We can possibly use a bias word in such a way so that it does not deteriorate any further. We can possibly have some kind of guardrails, which is what we are doing nowadays. A lot of different ways. So, open research topic. Okay. Anyone else? Come on. Go ahead. You have an opportunity to ask a question. Yes, no, maybe. Those who have not spoken anything yet, introduce yourself. Say something, right? Okay, all right. Why don't we do this actually? So I'll take 15 more minutes. If there are last opportunity, if there are no questions, I'll just introduce the topic for tomorrow a little bit more, right? Yeah.
So there is an option in ChatGPT. There is an option in ChatGPT, like when we give some information to it, it says that the memory stored or memory updated. So what does it actually mean? Is it learning from what I am telling you or just storing the information? And if it is storing the information, and when I make a new chat communicate, it recalls that information. So what should I interpret it with this?
Okay, so first of all, let me say I am not 100% sure what you're referring to. Were you using ChatGPT in a browser? Because you may be talking of something which is totally a client phenomena. There's nothing in the underlying model that does that. Now, the client interface that I have seen for OpenAI basically has a concept of a session, and it preserves your prior interaction. By default, it is going to use all of your prior interactions in the context till it hits the max size of the context. So if you have asked it 5 questions and in total they took 2K of space, it will continue to include it if you are using GPT-3, for example, which has a 4K context window size. Now, it also depends, I don't know how you use it. 4K window size for GPT-3 is only available in the paid subscriptions, not in the free subscriptions. So, I mean, there's a lot of unknown, I don't know which one were you using.
So,
3, 3.0, 4.
4.0, 4.0 there is specific limit for 4.0, and then after it switched to GPT-3.
Okay,
yeah.
Right. So, it could be that basically what it's referring to is how much of the context window have you used. So, there's a lot of it. So, think of it this way. The base model is one thing. How you are interacting with that model is another thing. It could be the client software that is providing all of it around it. So that's a possibility. Anybody else? Yes, no, maybe? Okay, all right. So let me just introduce a few things here, and then we'll see how exactly do we go about it. Perceptron, we have used the word before, right? I think this is the right one, yeah. So, does anyone remember what the perceptron is? That was the first implementation of a potential neuron, right? And this is very similar to what we have seen, and the slide is not 100% completed, so I'm going to be reusing it tomorrow, but we're just going to spend like 5 minutes on this and stop there. Very similar to what you have seen in a neuron or a neuron implementation. The reason I'm going to start with a perceptron is because this was historically the first thing. Take n number of inputs and produces an output. With proper weightages, this is actually implementing a NAND gate. Anyone remembers what the NAND gate is? And why is that important? So we talked about AND gate and OR gate and exclusive OR. NAND gate is negative AND. Why negative AND or NAND gate is important? Because this is called a universal gate. If all you know is how to implement a NAND gate, you can actually implement AND, OR, exclusive OR, all of them. So it's called universal gate. So same theory that we mentioned yesterday. If you can show that your perceptron can produce or act like a NAND gate, then theoretically it can do AND, OR, exclusive OR. Then basically you can have a perceptron or a set of perceptrons model a computer. Once you do that, then it can write a program. But that's a one thing. It can execute a program. And then from there it goes to generate the program, because it can do that as well then, right? So perceptron works exactly like a neuron that we mentioned earlier or that we focused on earlier. Summation of all the input going through a function, which is really a threshold function. If the sum total is above certain threshold, the answer is 1, otherwise 0. So I'm using it in the wrong way, in the sense that I've already introduced the neuron first, but the perceptron was the first thing that was discovered. Why we are doing it? Because tomorrow what we are going to do is that we're going to talk about the algorithms and the data structures that are underlying it. One more is those who are not the computer science or math background person, of some basic understanding and basic learning about the fundamental building block that we have used here. Okay? All right, so that's where we stop here. As I mentioned, that I'll just introduce that what we're going to do tomorrow. So that's about it. If you have any questions, I'm here. Feel free to come by or just raise your hand and ask the question. Yes, no, maybe? All right. Not a question. I don't know how Professor Sao is going to test you guys on, right? How many of you can write a paper? 2 pages, not more. Sorry? Based on your interest. So what I'm going to do actually next week was something for the next week, like come up with 4 or 5 different topics. Pick one and then combine that with whatever we have learned so far this week, and then see what you can come up with. And just like a paper, it could be a couple of different things. It could be a historical survey of where we are today, your learning of what you have done so far, maybe a potential direction of where you think things can go, your fears, where things can go wrong, people can misuse it. It can be used to do fraud. It can be used to do illegal things, criminal things, for example, a lot of different ways. Majority of the focus next week will be on these kind of topics. The social impacts, good impacts, bad impacts, risks, the ethical issues, the biases, the economics of the large language model. Like I mentioned, that there's cost involved. Right now you're being subsidized by the companies which are getting the investors' money. If they start charging the real cost of actually producing these outputs, it's going to be a lot of money right now. Right? So we're going to see this. There are a lot of companies out there right now. Worldwide, we have seen that that many companies with that many models won't survive because the underlying models are more or less same. Some models do one thing better, others do others better. Some models are closed models, which means that the weights and biases values are not known to anyone. Some models are open models. In the case of open models, weights and biases are known to you. What can you do if you have a weights and biases? 45 gig of database? Not much. But again, you can try to do experiment. If you are a computer science student, ask your department to basically download an open source large language model and see if you can tweak it, if you can figure out more details about it, what is happening in each layer. It's not that it's not possible, it is possible. All you need is the inclination, time, and resources, right? That's all you need. So once you have all of that, you can basically start looking and trying to figure out what all can you do or perform with that. All right, last opportunity. If there's any question, then we kind of break for today. Yes, no, maybe? Right, guys, great. Thank you. Okay. That's it? Do you want to disconnect it here?
Jadi itu yang